Yeah, it's
okay,
recording now. You're good.
Okay. So how these two guys are related to us as developers or to SQL Server? Well, originally we have all these SQL servers on site. We have physical servers and we deploy it there. And if anything was wrong, we usually just, the solution was just add more RAM or switch the hard drive to an SSD drive and stuff like that. So what we did was just try to add more power to the servers. But we cannot do that on Azure SQL because if we need to add more RAM or add more capacity, the costs are exponentially increasing every time we add something. So instead, if we have some queries running on a physical server and it's working fine, when we do the switch to Azure SQL or any cloud database, then we will suffer from performance issues, even timeouts and stuff like that, because the infrastructure supplied, it's limited based on the price model. So we're going to talk about the Azure SQL models, what I said at the beginning of the presentation. Basically, they have two purchasing models. The first one is the virtual core. It's the recommended one. This one is focused on adding or increasing memory or resources independent from storage. And it's not related to any DTUs. You just need to you just select 1 core, 2 cores, 3 cores, and go up. And the price will also go up on that. But the more traditional purchasing model is that database transaction unit, DTU. This is also is very limiting or how we do the implementation on the cloud, because once the DTU max cap is reached, then timeouts start throwing everywhere. Here's a simple comparison between both models. You can see that the DTU, the compute power increases at the same rate as the storage. And the big core model is independent from the compute power and storage. So you can move that, you can fine tuning that. But at the end, it's the same for us for performance. We are gonna try to reduce costs instead of just adding more power to the Azure SQL instances. So we're gonna focus on the DTU-based purchasing model.
Hey,
so
Jesus, I got a question for you.
Yes?
This is Ashish. So on the previous slide, would you have a recommendation on use cases to use one or the other?
It probably depends. I will go for the DTUs just because it's more simple to manage. You don't need to worry so much on adding storage or computing power. But at the end, what we are going to focus on this presentation is to lowering costs on both purchasing models. If we can lower the DTU consumption on one model, it will also benefit us on the big core models. So at the end, it's more a decision of who is going to be in charge of administering the resources. If we have a DevOps team, then it will be a decision for them to go one way or another. But for us as developers, we will need to focus on lowering the resource consumptions as much as we can, because on both purchasing models, we are going to benefit from a lowering price on the tires. Is that okay?
Yes, thank you. Actually, one more question. Is there anything related to the SQL Elastic Pool?
The Elastic Pool, it also will be, we will have benefits from that. The only thing that the Elastic Pool is that you have one pool of DTUs allowed for your services. So you can, if you have multiple databases, then this DTU pool will be used for one or another database. But if you have more than one database and all of the databases are running at full DTUs consumption, then we will end at the same scenario that we will need to add more DTUs for that.
Okay, thank you.
Okay, so for this DTU-based purchasing model, we will need to first answer what is a DTU. Well, a DTU is like it's a blend of multiple metrics. It takes into account the CPU used by the query or by the query you are executing. Also, the memory that is used, data input output, all the reads and writes that are made on the disk, and transaction input and output. That's the same. Every time we run a query, there is a transaction stored somewhere to have a consistency on all the actions performed on the database. So what does this mean? That this means that if we have a very heavy queries like store procedures or stuff running on the database, then it will for sure consume a lot of DTUs, or if we have triggers or updates based on triggers, so any kind of logic, use it or program it on the database side, will affect a lot on the DTU consumption, because on experience, we have seen that making queries to a SQL database on Azure is not so expensive. The more expensive DTU stuff that we have experienced are triggers and reports that merge a lot of tables or views or stuff like that. So once we reach the DTU cap, then we will gonna start getting timeouts everywhere, because the server is busy trying to allocate enough resources to finish one query, and all the other queries, probably more simple queries, are just putting on a queue. And if the timeout is reached, then just the SQL Server will respond with a timeout exception. So this will mean that we will need to add more DTUs, and more DTUs equals more cost. It's more expensive. Every time you go up a tire on the price model or on the price tires, the price it's doubled. I mean, if we have $100 on one instance, the next instance will be the double or a little bit more, up until I think it's the top for this purchasing model is like 1,600 BTUs, and that means something like $14,000 per month of the database. And if we are gonna have that expense, but with a simple application that probably doesn't have more than 1,000 users, it's not good for anyone. It's not good for the clients. It's not good for us. We're delivering some software that is not optimized for the cloud. So in order to reduce costs, we will need to reduce the DTU consumption. And the first thing to do with that are database optimizations. decided to.
Hey, Jesus, I got another question.
Yep.
So
Yep.
is the cost, when you're configuring the database, you see the cost at the bottom, it says, $95 or $200. Is that a fixed cost, or is that a max cost based on usage?
That's a fixed cost for the DTU
Okay.
purchase model, because what we are paying for for a quota of DTUs per month. So basically, we have this maximum amount of DTUs that will be used at specific moment of time. We can use, for example, 2,000 DTUs in a month, but space it with probably one day we use 100 DTUs, the next day 300. On weekends we don't use any DTUs for this, and that's okay. They are charging for a max amount of DTUs that will be available for us at a specific time on the application lifetime. So we are it's a fixed cost on the DTU purchasing model.
Okay, thank you.
That discussion? Okay. So we're going to continue with database optimizations. The first thing that we are tended to do when having a lot of issues is to add new indexes. We can on SQL Azure we can only have one cluster index, and all the secondary indexes are non-cluster index. So the first thing is to try to add non-cluster index to solve the DTU consumption, trying to reduce the reads and the memory used by the SQL server when executing one or another of the queries on the application. The second one is to reorder or rebuild indexes. So if we already have existing indexes, we will need to do this if the existing indexes has had a lot of fragmentation. If fragmentation is it's a disorder on the index. Basically, if you have an index, an alphabetic index, or on a column that is a bar chart, you expect to have all the values from A to C. But if your primary cluster index, it's another value different to this column, and you have a secondary index here, you will insert one value in a different order, and your index and your non-cluster indexes are are based on the cluster indexes. It's like somehow the row count or the row of your index is based on the cluster index. So we will end with a lot of fragmentation, and we'll need to reorder or rebuild the indexes. And the third optimization, it's more expensive. It's like we will need to modify the scheme of the tables that we have. We can do that taking into account the natural keys, and also noting that our primary keys on the tables should not always be our clustered indexes. We're going to talk about this in a moment. So we're going to go to the first optimization, add non-cluster indexes. We will need to take into account when adding a cluster index to try to keep the indexes as narrow as possible. Narrowing index means that it has as few columns as possible on this index. This will help us reduce the storage memory. And also we will need to take into account that more indexes means that it's a database harder to maintain. And also need to have into account that when we need to create non-cluster indexes on primary keys and foreign keys. And how do we do this? You just need to execute this this query, we need to create an index, the index name on a specific table, and just add the columns that we need to have it. The with online on, it's for executing on database on Azure, so we don't have to wait for a transaction to end. We can run this query at the same time that the database is used. So we will not need a window, a maintenance window to add more indexes. We can do that on the fly. And there are three kinds of non-cluster index. This is the basic one. It's just a non-cluster index. Then there are filtered indexes that are more small indexes, are more effective. It's the same query, just adding a where. So for example, if we need if we have a table with all the users login information, we can add an index to filter only the active users or the enabled users to just filter out data that it's gonna not be used by the application. So that's the use for the filtered indexes. You just need to add a where clause. Oh, sorry, just wanted to find it here. It's online. It's the same as on the previous screen. Okay, sorry. I think we move it forward to covering indexes. Well, covering indexes is similar to the filters one, but what we do here is to include columns that are queried, but not necessarily are filtered upon with a where clause. What does this mean? We can probably do a select from one of the columns that is not necessarily part of an index. We have it here. We created our index on 3 columns, column 1, column 2, and column 3, but also are including column 4, 5, and 6 into the index. So we are gonna do a select based or where column 1 is something and column 2 is something else, but we are selecting column 4, 5, and 6. So this will also help us maintaining our DTU consumption low. And this covers all related to non-cluster index. The next optimization will be reorder and rebuild indexes. So this is when we have a very fragmented index. We can execute this, we can create this store procedure and run it every time on our database. We will just need to send our table name as a parameter and get all the indexes created for that table, and also have all the fragmentations. The fragmentations will be a percent value like 21.62, stuff like that. And with this information, then we can go and alter our index. We are going to use reorganize when our fragmentation is between 5 and 30%. And if the fragmentation on each of the indexes is above 30%, then we are going to need to execute it with rebuild. So we are sending parameters like no recompute on and online on. It's just to, so we can be able to execute also this index reorder or rebuild actions on the fly, the same way as creating an index. We don't need maintenance windows to execute these commands on the database. We just need to be sure on which index we are going to execute and on which table. Sorry, I got the name wrong. It should be table name instead of database name on both of here. We need to alter the index name on the table name and then use reorganize or rebuild. Okay. So one of the reasons we have high fragmentation on our tables, on our indexes, is because when we created the tables by default, our cluster index was created over our primary key. Not always is a good idea to have this. So we can probably change the index, the cluster index on Azure, but we are limited or we are restricted to our data types. So if our primary or our cluster index is on an integer column, we can just modify that on another, it's also an integer. We cannot change our already existing cluster index from integer or one data type to another data type. We will get an exception. So we cannot create a new one because on Azure we only have one cluster index per table. We can have a lot of non-cluster indexes on each table, but only one cluster index. And also we cannot create tables, heap tables. These are tables with our indexes. Azure SQL does not support this. So we will need to create our primary or our cluster index over our natural key. So I'm going to show you an example on this. Suppose we have a user accounts table, and we have our primary key on or ID, it's our primary key, and we have the email. We are not gonna look for data based on the ID. Probably if a user just try to log in into our page, we will try to search on our email. But if we create, if we have the cluster index on our ID, then all of our secondary indexes or non-cluster indexes will be based on that. And we have a consecutive ID number, 1, 2, 3, 4, 5, but the email will quickly get out of synchronization or fragmented. You can see we have the alpha, zeta, gamma, alpha. It will be for performance, we will need to have this email sorted in an alphabetical order. So a better alternative for this kind of tables is to create our cluster index on the natural key, that the natural key will be the email, or any columns that we are gonna frequent use. So for example, if we are gonna store the data related to cars, equipment, we will probably have our natural key will be the serial number of that instead of an ID. That doesn't mean that we don't need to use a primary key based ID. We are just gonna change our cluster index from one column to a more natural column or columns. To do that, well, this was the example I was telling you. We have these table users with our ID, email, first name, last name, type. If we run this script as is, then our cluster index will be created on our primary key. That's the ID. So instead of that, we can modify our script, adding the create cluster index on the table that we have and the email. So these are good practices when adding a new tables. But what happens if we already have a table with a cluster index on a column that is not best suitable for our needs? Then we'll need to follow some steps to change this cluster index. These steps are needed to be executed on a maintenance windows, and we will need to do some backups and everything, because what we are going to do is to create a new table with the same columns, the same scheme that our actual table, just adding our cluster index on the natural key that we are going to use. We need to set the non-cluster index on the primary key to be sure that both primary indexes will be covered. And then we will need to copy the data from the original table to the new table, rename the tables. For example, we have our users table. We will need to create users underscore new, and then copy all the data on this users underscore new, and then do a table rename. So at the end, we will have users and users underscore old. And with that, we can just remove the original table. So these are very expensive steps, and we will need to be careful on when to execute that. And after trying all the other previous optimizations, we will need to do this to also lower our DTU consumptions. So any questions up here?
Can you hear me?
I think just a comment. I'm sorry. So if you're planning to move data into a different table, so probably you might also consider the foreign keys or any other keys that you have in your current table. So probably it might not be a matter of just copying the data from one table to another, but also you will have to recreate the keys and everything. So that's something to keep in mind while doing this. Although it might be a good option to do this. I mean, I've seen that some tables improve if we take the opportunity to redesign them. So I think it's worth the shot. And that's all.
Yeah.
So Jesus,
Thanks
I
for
have
the
a
heads up.
question too.
Yes.
So what is the use case for doing this change? If you're logging in, you're going to be querying for the user, the email address. But what if you're also joining a lot of other tables by the user ID? Do you have to take into account how many places you are creating a foreign key to the ID before you make this change?
Yes, as Javier mentioned it, I forgot to add those steps. Yeah, we need to take into account all the foreign keys and relationship on the database. So if we are using the same data, we are not changing anything else. We just need to create the new relationships, the new foreign index, the foreign keys. And then after doing the table rename, we will need to be sure that everything is working. Yeah, I need to update this and add a new step. For that, sorry for missing that out. But yeah, Javier is right. We need to take into account all of the related tables.
Okay, thank you. That makes sense.
Do you think you could share this with me?
Sorry?
Do you think you could share this with me?
Yeah, Alex, we'll have a recording and the slide decks available.
Awesome. Cool. Thank you.
Okay. Okay, so these are our database optimizations. Once we execute that, we can be sure we are gonna note less DTU consumptions on our database, but we can also do more on the code side. So we can go for code optimizations. I'm gonna be quick on this because almost all of us are very good developers. And this is just like a reminder on the best practices to follow when writing our code. So the first thing that we have to take into account is to reduce database calls. Yeah, for example, if we are running a loop for each or something, and on each item we are gonna go to the database to gather some information. So it's probably better to take into account just going once to the database, gather all the required data, and then work with that. Or for example, we may have we may be using mediator pattern, and on the handler we are gonna hit the database and then retrieve some data. And with that data, we will probably just need one ID and send it to another handler. And the other handler, we also go and based on this ID that we already retrieved from the database, we will go again to the database and retrieve the same information that we already had. So probably will be better to, if we already gathered data from the database, just pass it as an object instead of just the ID to go again to the database. Or for example, stuff that validating a user or stuff like that, that we just need to store on our local memory as a cookie or something that the user is already on the database. We don't need to go on each click on the application to the database. We need to reduce the database calls to also lower our DTU consumptions. Also, we will need to have into account the OR object-related mapping tools that we use, because these tools tend to create queries that are very complex, or sometimes we go to the database and just need one or two values, one or two columns from the database, from the table, but our tool will just go and grab everything and take all the columns, take all the information and load it into our memory. So we need to reduce our payload size to be more specific, probably on Hibernate using projections and stuff like that. Just grab the specific data that we are going to need to work with. And also, we will need to avoid overcomplicated queries. A good rule of thumb is to have no more than 4 inner joins or joins with another tables. Probably if we are doing more than this, we will need to think into a refactor, because these queries tend to get ugly as we add more and more joins. So if anyone has seen an Hibernate or an entity framework query, it has a lot of things that probably if you write this query on SQL, it will be more simple. So we need to have into account that. And the last one I want to mention is just to implement a cache. This improves a lot of the user experience. I'm gonna use an example. One of our clients needed a daily goals panel, and the data was, or the database server was on very high DTU consumption. So what we did was just to go to the database and grab all the data that we needed to display and store it in a local cache for all the users that will be logging into this daily goals panel, and also store a new, the last update time with the data. So every time the user click on here, we will configure how many minutes or the time needed to refresh the data. So we were just going to the database once every 5 to 10 minutes, and all the users are seeing the same information and have this. And it was very good performance improvement on the user side. So yeah, we will benefit a lot from using a cache. We can use the Hibernate cache, but if you need a more fine tuning, you just can use memory cache from .NET Core. It works very good. You just need to be sure your key names and adding your logic to how often to refresh this cache, and everything works very good. It's a must, I think, on our code. And that's all I have for you guys today. I don't know if anyone have some questions.
Jesus, I have a question. Have you used any of the query optimization tools inside of Azure?
Yes. Basically, tools tends to recommend if we are missing an index, and we'll try to create a new index and everything. But the scripts and the names and everything, it's not very fine-tuned. For example, based on current usage data on the database, these tools will recommend adding an index, or for example, on a serial number column. But then we add that index, and a couple of days after, then we will have another issue related to the same table, and this tool will recommend adding the same index, adding just a new column, and at the end, if we just go blindly clicking on create or okay, if you recommend that, that's okay. At the end, we have more than 3 or 4 indexes new related to the same column, with different columns aggregated on the same index, taking a lot of storage consuming a lot of storage from our database. And we need to maintain those indexes. Then we will need to rebuild, reorganize those indexes. And at the end, these recommendations are a good heads up. But I think that it's just, as it says, a recommendation. And then based on that, we will need to investigate more and see if we are good to use this recommendation or just modify something. So yeah, it's a tool that might help, but I will not blindly trust on that. Just use as a recommendation.
Okay, yeah, thank you. I know they also have the ability to automatically apply them and see if they helped improve it. Performance, it will keep it. If not, it will take them off. But it sounds like you recommend not to turn that on.
Yeah, it just need to be monitoring the database use, and if a new index is recommended by this tool, we will need to figure out exactly what we are, when are we going to use this data, or when are we currently using this data, and if we can do some performance or some optimization on the code or on the table current indexes, and then execute or the best actions based on that, instead of having it running automatically. Okay, any other questions? Well, just to wrap up, we talked about indexes, clustered and non-clustered indexes, and index management. We can benefit a lot from following this. I want to add that there are some new tools on Azure automation tools that already have a script that will monitor these databases. It will go through all the tables on a database and then check the indexes and how fragmented are those indexes, and then execute the rebuild, reorganize. And you can just go to the Azure automatization page and set it up and use data frequency. You can execute it once every 2-3 days, once daily at midnight or stuff like that. It's a good tool to just not do this manually.
And do you have to pay for that tool, Jesus?
It's part of the, I think, no, you just set up tasks. It's part of the Azure.
Is that included in the SQL account for Azure?
I think it's included. Just need to verify that.
Okay.
I have some homework to do. Okay. But yeah, it will be executed frequently and just do all this index maintenance, trying to have all the indexes with a fragmentation less. And just to finish this up, I'm just want to tell you that we need to learn like Team Taylor, more power, stuff like that, new frameworks, current newest versions, even if on beta, trying to do everything like him, but we will need to deliver like all, go for the safe route, the happy path, and be more like when delivering code, good learn like team. And that's all.
Thank you, Jesus.
Okay.
Thank you.
Thanks,
Thank you,
Jesus.
Thank you,
Jesus.
Jesus.
Thank you. Thank you.
Hey, thank you.
Thank you.
Very
Just
good
to let you
content.
know, one thing, just to let you know, well, first, thank you all for joining. And second, next week, we're going to have another virtual learn. It's going to be by Rodolfo. I'm going to send you information about this by email, okay?
Yay.
Thank you.
Yes.
Woohoo.
Okay.
Thank you.
What is it about? Do you know, Paulina?
Yes, give me a moment. The name that I have is Integration Testing with Docker in Azure DevOps.
Oh, cool.
Oh, nice.
Okay.
Yeah.
Yes.
So
Thanks.
nice.
Perfect.
Okay,
You.
so perfect. I think that will be it. Thank you all for joining.
Thank you. Bye.
Yeah.
Thank
Thanks,
you.
Jesus. Bye bye.
Thanks, Jesus.
Thank you. Have a good day.
Thank
you.
Thank you. Have a
Joy.
good day.
Enjoy your meal.